we are studying execution of complete instructions. So we will take this example. Add inside a bracket r3 comma r1 means content of the memory location addressed by r3 is copied to r1. Okay, so first, as usual, we should fetch this instruction. So we should fetch this instruction, then fetch the first operand, the content of the memory location pointed by r3 means r3 register is having some value. For an example, if it is having a value like 8000, that 8000 is an address. Okay, that value we should extract and that we should send to address lines, and from that address some location is selected and content of that location should be passed to a processor and copied to r1. Sorry, not copied to r1, that content should be added to r1. That is shown here. Perform the addition and load the result into r1. After the addition, the final results we should store in r1. So first we should fetch this instruction, then fetch the first operand. In the sense, fetch the first operand means here r3 is having some address, so 8000. That address we should send to a memory location, and the content of an 800 should be fetched and it should be copied to MDR actually, and that number should be added with R1. Perform the addition and load the result in R1, and final results we should store in R1. So we'll see what is an action. So fetch the instructions. So this instruction is stored in some memory locations. So that memory location address, assume that, is available currently in program counter. So program counter, it is available in program counter. We should send that to outer lines in the sense outer address lines. Okay, for that PC out we should enable, and the address comes here, then I should send the MAR in, I should enable, and I should send that to MAR, and this is connected to address lines. So what we need to do, the program counter value we should send to address lines. For that I should enable PC out, and address comes here, and I should enable MAR in. So it comes here, it goes to MAR, then from here it goes to address lines. This itself is written here. PC out I should enable, PC out I should enable, and MAR in I should enable, and I should generate read operations. Read operations is a read signal should be generated by this control logic. So especially there is a read bar or write signal is there related to read or write. So such a read signal should be generated from control signal. Then now, so usually program counter will update while executing the next instruction. That action should also begin now. That's the reason. So for already we have previously program counter value we have sent from PC out, and it is passing through this internal bus while flowing towards MARN, and the same data is we are sending here, it is coming here, and it is also coming to B. That's the reason this, what is the current program counter address is coming to B. To that I should add 4, means PC, it becomes PC plus 4, means it will point the next address. So that 4 comes from here. For that I should select, if it is connected to 0th input of the multiplexer, I should select input should be 0. That 4 comes here, then this comes here, 4 comes to output of mux, output of mux is connected to A. Now I should this 4 should be added to the PC value. So add operation I should start. For that purpose, this controls unit should generate add signal. So add operation will be performed and the results is copied to Z register. For that, Z in I should enable. So that is shown here. So after select 4 means mux, this selection line should be made. For an example, if this is connected to 0, it should become we should make this 0, so that this 4 will be coming as an input. So this input is selected and add signal should be generated. Then Zin should be activated, so that intermediate result goes in Z.